So now we're going to go ahead and begin the Q&A session with all of the presenters. So for our first question, in the urban coastal areas of the East Coast, the flood water often starts as surface runoff from inland areas into the coastal areas. Is anyone including upland stormwater runoff in sea level rise or storm modeling?
This is Patrick Barnard. Right now we're developing an operational model in partnership with the National Weather Service in San Francisco Bay, which includes discharge from the watersheds in addition, coupled with the coastal storm modeling system. So coupling basically ocean-based flooding with river watershed-based flooding. And so that's so one instance where that's being included along in this example from the West Coast, but of course I can't speak specifically to what's going on the East Coast.
So this is Maria Honeycutt with NOAA, and I'll get out of my depth really quickly, but I did want to mention NOAA has been working with partners in the development of what we're calling the National Water Model, which is an operational model covering the United States. And long story short, one of the aspects that is still evolving in the National Water Model. It's mostly inland at this point, if you were to go check it out. But we are working on building the coastal component and marrying the two because, of course, many communities get hit from both sides. But that is still a ways down the line in terms of fully coupling the inland story with coastal water levels.
Yeah, this is Jennifer. I can say, too, that here in Georgia, we've just actually signed a contract with the university, with Indiana University, the Polis Center, and the University of Wisconsin to run HAZAS for us, looking at stormwater rain precipitation events, as well as running sea level rise. They did some hydro modifications to the depth grids to incorporate sea level rise with some of our slosh modeling. And so there's a little bit of issue of running them together without double counting them and their impacts. But we are starting that as a new 5-year project where we will be looking at that. So I think that the technology is there. It just needs to be tweaked a little bit.
Thank you all. Next question. Is the Coast Our Future tool only for California? And I imagine the questioner here would be curious if it could be used on other parts of the country or other parts of the West Coast.
Yeah, it's only being used with Cosmos in California presently, possible expansion to Washington and maybe at some point Hawaii. But it is a flexible system that could be populated with flooding data from virtually any source. And of course you have surging seas and you got the NOAA Sea Level Rise Viewer, and those are the main tools, main national tools, but our Coast Our Future is currently just a regional tool for California.
Thank you. Next question. Several modeling software tools and programs have been referenced by the various speakers. Which of them are available to the public and might also be appropriate for use by high school freshmen for project-based learning? And that's a great question.
So this is Maria from NOAA. Everything that I showed is available publicly and online, and hopefully you were able to catch. I have URLs embedded in my presentation, and I think they should work in the version that is provided for download. So all of the resources that we have talked about and that we provide links to are public-facing.
This is Jeff. While it's only for the Texas coast, the Coastal Communities Planning Atlas is also available to the public and I think would be appropriate for use by high school freshmen.
Yeah, same thing here for our Coast Our Future. It's a very simple, publicly facing tool, and actually there's been a considerable outreach effort to get into high schools and middle schools to get kids to use this and learn more about the impacts of sea level rise and storms.
Thank you. Next question. I've read that approximately 40% of the world population lives within 100 kilometers of the coast. However, one of our speakers cited a lower number, so they were just wondering what the criteria are for those numbers.
This is Patrick. Often the numbers cited are for the coastal zone within 10 meters of current sea level. And so the number I cited for 1 billion people is for the coastal zone and that elevation of 10 meters or less.
Thanks. Next question. How do state environmental policies interact with coastal hazard mitigation efforts at the local and regional level? And maybe our state and regional speakers can talk a little bit about their experiences with this.
This is Jennifer. I know in Georgia, we our local level follows our state for their hazard mitigation for planning, and so I mean they have to be consistent that they get the funding through the state and actually through the federal level to kind of do this. So as far as mitigation efforts, they kind of it's a pretty set framework and that they pretty much follow. They don't really vary much from each other. I don't know if that answers that.
The same in Texas. Our hazard mitigation plan has to be approved by the state and consistent with them. I would say in particular in the state, the General Land Office is the chief agency, and they're very much a partner in these storm defense studies and also in looking at some of the non-structural approaches. And the state is actually also very heavily involved in the usage of the Restore Act funds from the Horizon oil spill disaster, and I think they're really looking at multi-benefit projects that can also, in addition to providing some hazard mitigation, can produce other habitat and environmental benefits.
In California, the state very much leads the effort in terms of sea level rise guidance and adaptation efforts, and they control a significant amount of grant funds for local governments to plan for climate adaptation and mitigation efforts. There's a lot of back and forth at the state level, particularly the California Coastal Commission, the Ocean Protection Council, and the California Coastal Conservancy, down to the local level. There's a lot of back and forth and a lot of sort of discussion on how those policies are implemented at the local level, and the locals look to the state primarily for guidance in all these aspects.
Thank you. All right, next question. Rising water from overland flow is also affected by land use. How are changes in land use being incorporated into the models, which do tend to focus on sea level rise?
So speaking for NOAA and our viewer, and I think Patrick started to hit on this as well, ours is a static system. We use high resolution LiDAR topographic data as the basis of the mapping, and it is not something that is sensitive or considers in any way land use or other even geomorphic change that may happen over the course of time. But maybe Patrick might want to say more about the capabilities of some of their models.
In Cosmos, we definitely evolved the coast, so it dynamically responds to sea level rise and storms. However, I'm not aware of any comprehensive models anyway that really look at future changes in land use throughout the U.S. I'm sure there are a few local efforts that look at those changes in terms of hardscape versus softscape. And in San Francisco Bay, there's considerable effort to look at changing and restoring tidal marshes and how that's going to affect future flooding. But I'm not aware of any models that incorporate so robustly those potential changes in land use into their flooding projections.
I would add, this is one of these areas where I see the community needing to go. When I spoke earlier about the need for more integrative models, we have in the extreme event space, modeling space, a variety of ways of accounting for land use when you're looking at overland waves, for example. And what we haven't quite riddled out is how to marry some of those and the scales at which those operate with some of these other broader processes, the sea level rise and other things that are happening on different time scales and different spatial scales. But it's something that, as somebody who started in this field by working on coastal flood modeling and very narrowed down on that transect by transect scale and looking at overland waves parcel by parcel, finding ways to efficiently scale that up and incorporate that into these integrative models that are both extreme events and sea level rise is a big challenge. But ultimately, to have credible information on land where people are and buildings are, ultimately you're going to need to try to account for that information.
You know, that is, this Jeff, I think a great opportunity for some collaboration between the federal agencies and universities and local entities like ours. Our land use model, we can actually get some coarse estimates of increase in impervious surface. I would be hesitant to say those are really credible for modeling yet, because they don't take into account urban storm infrastructure, they don't take into account on-site detention requirements and the like. But we do have a forecast of land conversion. I'm guessing that other regional agencies may have similar things. So I think that's something we need to continue working on together.
This is Jennifer. We are actually doing this here in Georgia. We just started on a project I was mentioning a little bit earlier, where we are going to be modeling riverine flooding and coastal flooding, including sea level rise. We're going to be doing that with existing build-out and with potential future build-out, and then also doing that with and without green infrastructure, and with and without the preservation of wetlands and sand dunes. So we're working on that with, again, with the Polis Center at Indiana University and the University of Wisconsin, and NOAA has done the exact same project up in the Great Lakes several years ago as a good pilot study. So I would encourage people to go and check those out.
Thank you. Next question. For Jeff, is your council's resilience initiatives directly related to the Greater Houston Wilderness Project, which is a regional system of green and open spaces?
Yes, we sit on their advisory panel, and really Houston Wilderness has taken the lead in trying to come up with a unified and consensus list of projects that, you know, both provide the storm defense features, but also are critical habitats and provide recreational opportunities. So I would say we're well integrated into their process.
Thank you so much, Jeff. And we're just going to wrap it up with one more question. This is from me because I know how hard it is to get information about this. So for the students in our audience or people thinking about their future careers, would you all say in just a few words how you got to what you're doing now?
So this is Maria. Maybe you'll go in order of presenters so everyone knows when they're on the hook here. I would say I would credit my role today. The first step in that process was a fellowship that I did after my master's degree, sponsored by the Sea Grant. It's the Canals Marine Policy Fellowship, and I happened to serve that year almost 20 years ago at FEMA, and really enjoyed the opportunity to learn about FEMA's mission and see up close and personal how the work of a scientist or an engineer can help alleviate suffering. If you do your job right and help identify hazards and people avoid harm, gosh, it doesn't get any better than that. So that's where it got me started.
That was Patrick. Yeah, a few words. Okay. Well, I grew up on the beaches of Southern California. I sort of grew up with through this major El Nino of 82, 83, when all my favorite piers were destroyed. So I became really interested in coastal processes and storms. And when I was fortunate enough to land at the USGS, after too much school, I began really looking at storm impacts and sediment transport, but the realization across the state was that, for me, there's a lot of decisions being made related to climate change with very little science to support it. So kind of moved our group toward focusing more on climate change impacts as opposed to sort of modern day coastal processes and impacts based on the expressed need of the public and the state agencies to have science to drive their policy decisions.
This is Jeff. I kind of went in the opposite direction. I have an undergraduate degree in life sciences, and I worked for my alma mater for a couple years trying to decide what I wanted to do, and I realized that I was more interested in the policy part of it than the science per se. So I got into urban and regional planning and started out working as a city planner, and then went to work for the regional council where I'm at now. And I found there was this whole opportunity to reintegrate a lot of what I knew about natural systems with urban development policy. So it was just a wonderful marriage of those two for me. The other thing that has been so exciting, having been at this for a long time, is the evolution of the tools and the data we have to put those sort of decision guides into people's hands that don't have the science background is just phenomenal. And I think we're just getting started on that.
This is Jennifer. I too have a background in environmental geography and geology, and I've been with the department for 16 years now, and I think that just probably halfway into my career realized how unprepared we are in Georgia for a lot of, and you may have heard some of this on the news, how unprepared we are for a lot of the natural disasters that we have here. And so I think just being prepared has really kind of urged me to continue working towards that balance. And then, of course, as everybody knows, there's somewhat of an adrenaline rush when you start to work on coastal hazards. So that always helps.
Thank you all so much for talking a little bit about your background. That's really interesting. Well, okay, everybody, thank you so much for sticking with us for this long webinar today. We're so happy to have you, and thank you for your excellent questions, and especially a big thank you to our amazing speakers for your great talks. If you have any questions that were not addressed today, you can email them to us at cipinfo@americangeosciences.org, and we'll make sure to send your questions along to the speakers. We'd like to invite you to join us for our next congressional webinar, Building the Modern World, Geoscience that Underlies Our Economic Prosperity, which will be on Wednesday, August 2nd, 2017 at 3 p.m. Eastern Time. This is based on a congressional briefing that our geoscience policy team held in early June, and we're expanding that into a special webinar. So it should be a great event. We really hope you can join us. We'll be posting today's recorded webinar on our Critical Issues webinar page very soon. You can visit the website to view this webinar as well as previous ones on a wide variety of geoscience topics, and the slides from this webinar today will also be shared there. Thank you so much, Maria, Patrick, Jeff, and Jennifer, for sharing your time, expertise, and insight with us. This concludes our webinar for today. Thank you all again for joining us, and we look forward to seeing you next time.